Hello, welcome to another A-Level Maths video. Here we're looking at the Pure Maths Year 1 contents, looking at Chapter 2 of the textbook, Section 2.4, where we're going to be sketching some graphs of quadratic functions. So let's see what we remember from the last video about quadratic functions. Here's a question on the screen. Pause the video, have a go at it, and restart when you're done. Okay then, so here's our function. Now we've been asked to do two things. The first thing is to find the value of f of 0. So remember what that means. We have an input value of 0. So wherever we see x here, we'll write 0 instead. Okay, and this one's nice and easy to work out because any term which involves a 0 in it is just going to become 0 itself. So the only term that we've got left here is the -4. Therefore, when the input of the function is 0, the output is -4. Okay, so let's move on to look at the roots of the function. Now, do you remember what the roots of the function are? The roots of the function were the input values which give us an output of 0. So what we want to do is we want to find any values of x where when we feed it into the function, we get an output of 0. So we just end up with a quadratic equation to solve. Now, I solved this one by doing a bit of factorizing. And I got my answers here that x equals 4 and x equals -1. So those are my two roots of the function. Now, up until now, we've not really been looking at the graphs of functions, but if I get my graph plotter on the screen here and actually plot what this function looks like as a graph, then you'll see the picture that's just there. So hopefully you are familiar with graphs before, graphs already, I should say. You've seen them before. But the values we've just worked out as part of the question you've just done, when we put an input of 0 in here, we got an output of -4. And can you see that relates to a particular point on the graph here? It's where the graph touches the y-axis. And the reason for that is because when x equals 0, that means that we're on the y-axis here. Any point on the y-axis has an x-coordinate of 0. So if we want to find where a graph touches the y-axis, then the easiest thing to do is just substitute x equals 0 into there and get that answer. Okay, but what about the roots of the equation? Because we did that as well. Well, those also relate to points on the graph as well. And these are where the graph touches the x-axis. And if you think about it, that should make sense because we want the output to be 0, so we want the y values to be 0, and we get that with an input value of -1 and an input value of 4. Those are the roots that we found in the previous question you just did. And these are important points to know about whenever we're trying to sketch a graph. So sketching a graph doesn't mean accurately plotting it. It means drawing a quick picture which has the important features on it. And some of those important features might be where the graph touches the axes. Here are some definitions and some methods on the screen here. If we want to find where a curve meets the y-axis, we substitute x equals 0 into it and we find any y values there. That point is called the y-intercept. If we want to find where a curve touches the x-axis, we just substitute y equals 0 into the equation and we solve for x. Any points we find, the roots of that function, are called x-intercepts on our graph. So why don't you have a go and see if you can do this yourself. I've got a quick question on the screen for you. I'd like you to just, for the equation of the curve that's there, find the coordinates of any points where that curve meets either of those coordinate axes. All right then, so here's what you hopefully did. To find the y-intercept, we need to substitute x equals 0. We need to work out where the y-coordinate is when x equals 0. So let's just take our equation here. So we have 3 lots of x squared, so in this particular case 3 lots of 0 squared, plus 16x, which will be 16 times 0, plus 5. And that means that any of these terms with x in just vanish away to 0, and so we just end up with 5 here, which means our y-intercept must be the point with coordinates 0, 5. Okay, let's see if we can find our x-intercepts. So that means we need to find the roots of the function. In other words, we need to set y equals to 0 and see what we get there. Now, if we do that, we end up with 0 equals 3x squared plus 16x plus 5. And we've got ourselves a quadratic equation to solve. I solved this one by factorizing. And that's what I got there. And if you then use that, you can then just write down the answers there. That's x equals negative 1 over 3 and x equals negative 5 are the roots. So therefore, our coordinates of our x-intercepts must be negative 1 over 3, 0, and negative 5, 0. Do you agree? Let's just have a quick look at the graph on the graph plotter. So this is the actual graph we were looking at here. The y-intercept, it's right there at 0, 5. And then our x-intercepts, we can see there, negative 5, 0. And the other one here, now that's negative 1 over 3 written as a decimal. So we are good and we've got the right answers. Okay, so that's how we're going to find our x-intercepts and y-intercept. So that's where our points, where our curve or our graph touches the axes. But there's one other really important point to know about on a quadratic curve as well. And when we are sketching quadratic curves, we quite often want to know about where that minimum or maximum point is. And to lead us into that, I'm going to ask you to do the question which is on the screen. Can you take the function which is on the screen there, write it in completed square form, and then determine the minimum value of that function through doing that? Okay, remember we did this in the last video, so let's see what you can remember. Okay, let's have a look at this one then. So here's our function. And now we're going to need to write this in completed square form. So we're going to take the x coefficient, we're going to divide it by 2, and that's the number which is going to go inside the bracket here. We're then going to take that number that we've just written down, and we're going to subtract the square of that number away. And then we've still got the minus 4 hanging around here like this. Okay, so do you remember that technique from the previous section of the book? I hope so. Let's just tidy this up. So we end up here with x minus 3 over 2 all squared. And then the negative 3 over 2 being squared, I think becomes 9 over 4. And then just collecting these terms together, we're going to end up here with x minus 3 over 2 all squared minus 25 over 4. So there we go. We've written it in our completed square form. Now, do you remember why this was useful? How did this help us find the minimum value of the function? Well, do you remember the idea that the squared part of what we've written down here can never be negative? So the smallest possible value that could be is going to equal 0. And so when that bit equals 0, the minimum value we're going to get for the whole function has got to be minus 25 over 4 there. So the minimum value is going to be negative 25 over 4. And that's going to occur when x is whatever makes this bit of the bracket here equal 0. That is 3 over 2. So let's see how that looks like on the graph here. We've got this minimum value of minus 25 over 4. We know the x value where that occurs is at 3 over 2. And if we look at the graph of this function again, what we'll see is that this minimum point down here, this point where it's at the bottom of the graph here, that has coordinates. There we go. The x-coordinate is 3 over 2, or 1.5. And the y-coordinate is the minus 25 over 4, which written as a decimal is minus 6.25. And can you see those were the coordinates, or those were the numbers that we found exactly here? This was our x-coordinate of our minimum point on the curve, and this was the y-coordinate, the actual value there. Okay, so hopefully this is all making sense to us here. Now, let's just sort of piece all this together so we know what's going on. There's a bit of vocabulary which I've not been using yet, which I'm going to start using. So let's introduce that now. So the shape of the curve, or the shape of the graph of a quadratic function, is called a parabola. Okay, that's a word you may or may not have heard before, but that sort of U-shape that we get whenever we draw a quadratic graph, it's called a parabola. And the point we've just been talking about, this sort of maximum or minimum point on the curve, we sometimes call that the turning point on the curve. Other people call it the vertex here, but our textbook and our course, we're going to call it the turning point on the curve. And here's the method of finding where that turning point is. We need to use that completed square form for our quadratic. So the first thing we will do is write that quadratic function in completed square form. Then what we're going to do is we're going to work out that minimum value of the function, or sometimes a maximum value of the function. That's going to be the y coordinate of the turning point. And then the value of x, which gives us that minimum or maximum, is the x coordinate of the turning point. Have you got the idea? I hope so. Let's see if you've got the idea, because I'm going to ask you to have a think about the question which I've now put on the screen. Now, here's a curve. It's a quadratic curve, and I've already done the first part. I've already put it into quadratic. Sorry, let me say that again. I've already put it into completed square form for you already. What I want you to do is just write down or state what are the coordinates of the turning point on that curve, please. Okay, so here's our equation here. Now, the turning point is going to have the y coordinate equal to whatever we get whenever with this bracket here is 0, because that's the most extreme value we can have there. And that's just going to be -1 here. So our minimum value for y is going to equal, okay, let me say that again. I think I'm just going to correct myself here, because I don't necessarily think it is a minimum, but our value for y for the turning point is going to be -1, okay? Because that's what we're going to get when we have this bracket here equaling 0. All right, the x value, which makes that bracket equal to 0, is going to be -3. So I think our turning point must have coordinates -3, -1. Why don't we look at the graph plotter to see whether or not it agrees with us here? So this is what our curve looks like in this situation. Our turning point is right here, and that does indeed have coordinates -3, -1. So it turns out completing the square is quite useful for us, right? Because it gives us these minimum or maximum points on the graph. Now, I just want to make an observation here, because this particular graph, unlike the other ones we've done so far, seems to be the other way up. And there is a reason for that, which is that if we have a curve with an equation here where the x squared coefficient is positive, so that's the a in our formula that we've got there, then we always end up with a curve which is sort of like, it seems to be like a smiley face. Yes, we're smiling there. And the other one is frowning. It's kind of upside down. So when a is positive, then we have the shape you can see on the screen there. When a is negative, we have that upside down version. So now, with all of our knowledge that we've just got here, let's see if we can just piece everything together and sketch a curve from scratch here. Let me show you how it works with the one that I've got on the screen here. So we have the curve y equals 16 minus 6x minus x squared. First thing we can say, what's the shape of that curve going to be? Well, the x squared coefficient is negative, so it's going to be one that looks a bit like that. What's the y-intercept going to be? Well, the y-intercept is when x equals 0. That's going to happen when we put x equals 0 into here. We're going to have 16 minus 0 minus another 0, so the y-coordinate is going to be 16. What about our x-intercepts here? Well, we need to solve the equation. 0 equals 16 minus 6x minus x squared. Okay, when I solved this equation earlier on, I got the roots here as -8 and 2. Okay, so you can either factorize or use the formula to solve that equation. And then the turning point, we need to have this in completed square form. So when I wrote it in completed square form, I'll just jump to what I got here. I had, this is the completed square form. So therefore the value, the y value is going to be what we get when this bit is 0. So that's going to give us a y value of 25. And the x value is going to be what we end up with, what value of x ends up giving this a value of 0, which is -3. So with all of that information, let's see if I can actually now sketch this curve. Okay, so let me draw some axes. What do I know? I know the y-intercept is at 0, 16. So I'll just put 16 here like this. Notice I'm not measuring anything out. I'm not putting any tick marks along the axes here. I'm just doing a sketch. The x-intercepts, the roots, happen at -8 and 2. So I'll just put those roughly about here, 2 there, -8 here. The turning point is at -3, 25, so -3, and we'll sort of have 25 about here. So there's our turning point here. And we know the overall shape is this one, which kind of looks a bit like it's pointed upside down. So putting all that together, it means I end up with my sketch, which looks a bit like that. Okay, good. Now this question did ask us to do one last thing. It asked us to state the equation of the line of symmetry of the curve. Well, hopefully you can see that this curve is going to be symmetrical about that vertical line here, and the equation of that line is x equals -3. You can see it's the same as the value here where our turning point is. Okay, so hopefully that all made sense to you and you saw everything that we need to do in order to do a sketch of a curve, a quadratic curve here. I'm going to see if we can finish off this video by you doing a sketch of your own here. Have a go at the one on the screen here, pause the video and restart once you're done. Okay, how did you get on then? So this is what we should have ended up with here. So this was the one that you were asked to sketch here. The shape, well, first of all, notice that the x squared coefficient is positive, so it must be one of these ones here. The y-intercept, well, that's going to happen at 0, 10. So when you substitute x equals 0 into here, you should get y equals 10. The x-intercept, well, if you substitute y equals 0 and solve the equation, you get the two roots are 2 and 5/2. So we've got our x-intercepts here at 2, 0 and 5/2, 0. And then the turning point, when you write it in completed square form and work out the turning point, you should get the x value is 9/4 and the y value is -1/8. Okay, so putting all that into the graph, x-intercept at 0, 10. So let's put that up there, 10 about there. Sorry, did I say x-intercept? I meant y-intercept there. So y-intercept at 0, 10. X-intercepts happen at 2 and 5/2, so we'll put those there, 2 and 5/2. 5/2 is of course 2.5. And the turning point is at 9/4, -1/8. So that's sort of somewhere between here, round about there somewhere. And so our curve must look a bit like that. Okay, and then finally the line of symmetry is this vertical line here, which goes through the turning point. So that will be x equals 9/4 there. So how do we feel about quadratic graphs and sketching quadratic graphs as opposed to plotting them? Hopefully you're good, but if you need a bit more practice, then exercise 2F is the place to go in the textbook. But for this video, and I'll see you again next time.